Hello, this is Mrs. Ward, and these are the notes from section 4.1, the derivative in the tangent line problem. So what we're going to do in this section is we're going to find the slope of a tangent line to a curve at a point. Then we're going to use the limit definition to find the derivative of a function, which means we can then find the derivative at any point. And then we're going to understand the relationship between differentiability and continuity. So we're going to start with what's called the tangent line problem. So if you look at this picture here, we have this graph, we have C and then F of C. And then we go over here, delta x, and we have a new point, which is C plus delta x. So like this is C, delta x, this is C plus delta x. And then we have this other point, and then the height would be that F of C plus delta x. So this equation is a slope, so it's the difference of the y's over the difference of the x's, and the difference between these two is just the dx. So that's going to find the slope of the secant line. Remember, secant line is if I take any 2 points on a graph and I connect them, that forms a secant line. Eventually, what we're going to do is we're going to take those 2 dots and we're going to move them closer and closer together till eventually they end up as just touching the graph once, and then it becomes a tangent line. In order to do that, if we're bringing these 2 dots closer and closer together, this delta x has to approach 0. So that's why we have to learn how to find the limits, because we're going to find the limit as delta x approaches 0. So the first time we do this problem, we're going to find the tangent line at a certain point. So we're going to find the tangent line at the point C. So this is the same formula you've seen a couple times. You're going to take the limit as delta x approaches 0. You're going to find f of c plus delta x and then subtract f of c. And we're going to find the limit as delta x approaches 0, and then we're finding the tangent at the point C. So let's start off with the first one. It says find the slope of the graph of f of x is equal to 3x minus 7. Use your results to find the equation of the tangent line at the point 4, 2. And that's a typo. It should not be 4, 2. It should be 4, 5. Because if I put 4 into this equation, I would have 3 times 4 minus 7, which is 12, minus 7, which is 5. So that ordered pair should be 4, 5. So what I'm going to do is I'm going to do the formula, which says I'm taking the limit. And then back here, remember, we're taking as delta x approaches 0, as delta x approaches 0, of f of c plus x. I'm just going to c plus delta x minus f of c all over delta x. That's the formula. So now what I'm going to do, and yes, you need to know that. I'm not going to provide that for you. So I'm going to say c plus delta x. So every place I see an x here, I'm going to put in c plus delta x. Remember, this x is my c. So I'm going to say, I'm going to find f of 4 plus delta x minus f of 4 all over delta x. This is the specific problem that we're doing. So now I'm going to find, in place of this x in this equation, I'm going to put 4 plus delta x. So I'm going to have 3 times 4 plus delta x minus 7 minus f of 4, and we said f of 4 is 5. We've even figured it out. So minus 5 all over delta x. And remember, you're writing this limit as delta x approaches 0 down the whole problem. It's really messy, so sorry. So now I'm going to have 12. I'm distributing, so I'm going to have 12 minus 3 delta x, and then minus 7 minus 5 would be minus 12 all over delta x. The 12 plus the negative 12 is equal to 0. So now when I take the limit as delta x approaches 0, it was plus here, and I need a minus there somehow. So then I'm going to have 3 delta x over delta x. That's a factor, so I can simplify it. So my slope of my secant line is going to be 3, and just 3. And I kind of should have expected that. And the reason why I should have expected that is if I go back up here to my original equation, This is a linear equation. This is a line. The slope of the line is 3. Well, if you think about a linear equation, it's going to have a constant slope always. And any point on here is going to have a slope of 3. So I should not be surprised by that answer. The next one, find the slope of the graph of a nonlinear function. So find the slope of the tangent line to the graph of the point of the function f of x is equal to x squared plus 4 at the point 0, 4, and 2, 8. And so I am going to have to do this one twice. First of all, I'm going to do the limits as delta x approaches 0 of 0 plus delta x minus f of 0 all over delta x. So we agree that 0 is 0, so I'm just putting delta x in here. So when I find the limit as delta x approaches 0, I'm going to have delta x squared plus 4 minus f of 0, which is this 4 here, all over delta x. Then I'm going to take the limit as delta x approaches 0, and the 4's will equal 0. And so I'm left with delta x squared over delta x. And remember, one of those delta x's will simplify. So I'm left with delta x over 1, or just delta x. And the last thing I'm going to do is substitute in the 0 for delta x. And so the slope of my secant line, let's see about that the wrong way, is going to be 0. At the point 0, 4, the slope of the secant line is 0. And that should make sense, because if I were going to graph this, this would be a parabola. Oh, I kind of do that wrong, where the vertex would be at x is equal to 0. Now let's do 2, 8. That might be a little more exciting for us. So I'm going to take the limit as delta x approaches 0 of f of 2 plus delta x minus f of 2 all over delta x. Again, you're going to have to know this formula. The c in this case is 2, and that's where I got those numbers. So I'm going to put 2 plus delta x in for the x, so that's squared, plus 4 minus f of 2, which is this y value, which is 2 all over delta x. Now I'm going to FOIL that, and you should remember from Algebra 1, the Algebra 1 memory box here. If I had a plus b squared, that ends up being a squared plus 2ab plus b squared. So that's how I'm going to jump to this next line. So I'm going to say 2 squared would be 4 plus, this is 2 at delta x, double it, so 4 delta x plus delta x squared, and then this ends up being minus 4 all over delta x. Now the 4 and the negative 4 end up equaling 0, and everything else that I'm left with has a delta x. I must show that I'm factoring out the delta x before I can simplify the delta x. So I'm going to factor out the delta x. When I factor out from here, I'm going to have a 4. When I factor out from here, I'm going to have 1 delta x left, and this is going to be over delta x. Now that delta x is simplified, take the limit as delta x approaches 0. Since I got rid of delta x in the denominator, it's okay for me to substitute the 0 in. So I'm going to have 4 plus 0. So the slope of the secant line is going to end up equaling just 4. So that is the slope at the point 2, 8. The slope is 4. At the point 0, 4, the slope is 0. So that's me finding a slope at a point, one single point. So I'm only finding the slope at 0. I'm only finding the slope at 2. And there has to be a much more efficient way to do this, so I don't have to keep on doing all this work every single time. And that's where we come up with this, finding the derivative of a function. And this will give me an equation to find the derivative at any point. This formula also you need to memorize. This is the limit. It's similar. The limit is delta x approaches 0. But instead of having f of c plus delta x, I'm just going to write f of x. Instead of subtracting f of c, I'm going to subtract f of x. So this will give me an equation that tells me the formula to find the slope at any given point. And down here, you'll see these are the different ways that we write derivative. We write derivative with a prime, like f prime of x, that means derivative. Sometimes we write dy over dx. That becomes important later on when we do implicit differentiation. Don't worry, we'll get there. This sometimes, instead of saying f of x, I can say y, so y prime. And then here we have the change in dy dx. That means I'm taking the derivative in terms of x, which we are going to do. And then sometimes, very rarely, you see it like this. I think a lot of colleges use this way, though. I'm not sure. So when I'm doing this, when I do this whole process, I'm going to end up with the derivative. So instead of writing the slope of the secant line, I'm going to pick one of these formulas, one of these methods to write the derivative notation. So let's just do one. Find the derivative by the limit process. That is considered also known as the definition of the derivative. Those two mean the same thing. Limit process, definition of derivative, still going back and using this formula here. So I'm going to take the limit as delta x approaches 0, and I'm going to take f of x plus delta x minus f of x all over delta x. This is going to be the same formula every single time if I'm finding the equation. So in place of x, I'm going to write x plus delta x. So I'm going to write x plus delta x cubed plus 1, and then minus f of x. So I'm going to write minus, and then I'm going to put this in parentheses. And this is all over delta x. Just to show you what I've done, this f of x plus delta x is this part here. And minus f of x is this part here. And then there's the delta x stating delta x. Okay? So now I have to raise this to the third power. I wonder if any of you remember the binomial theorem. If you don't remember the binomial theorem, you're going to have to take x plus delta x and square it. And when you do that, you get x squared plus 2 delta x plus delta x squared. And then multiplied by x plus delta x. That would be to the third. Take this and multiply by x plus delta x. So I'm going to get x to the third plus 2x delta x plus x times delta x squared plus delta, I should write the other way, x squared delta x plus 2 delta x squared plus delta x third. And then I think my only like terms, okay, so I'm going to write, I knew I made a mistake, and here it is. When I multiplied this, when I FOILed this, it was x times delta x, so it's 2x delta x. Now I multiplied by this x, so it's 2x squared delta x plus x delta x squared plus delta x to the third. And so then here are these two are like terms, and these two are like terms. And so I end up with x to the third plus 3x squared delta x plus 3x delta x squared plus delta x to the third minus, oh, well, forgot my plus 1, got this little guy here, plus 1 minus x to the third minus 1 all over delta x. Now the x cubes will equal 0. The 1 and the negative 1 will equal 0. Everything I have left has a delta x, so I'm going to factor that out. So I'm going to have delta x times 3x squared plus 3x delta x plus delta x squared all over delta x. Delta x is simplified. Now, since I've gotten rid of that delta x in the denominator, I can substitute 0 in for delta x. So I'm going to have 3x squared plus 3x times 0 plus 0 squared. And then multiplying by 0 will make it 0. So now the slope of my tangent line, so I'm going to write f of x prime to show that it's the derivative is 3x squared. Now if I wanted to find the derivative at any point, I would just substitute it in. So it wants me to find the derivative at -2, -7. So I'm going to find this f of -2. And when I do that, I get 3 times -2 squared. So that'll be 3 times 4. So the slope is 12. So the slope at that point is 12. The slope of the tangent line at that point is 12. But it doesn't just want the slope. It wants the whole tangent line. So I am a huge point slope person. I love point slope. There's slope intercept and point slope. I prefer point slope, so everyone I'm going to do is point slope. Just a reminder, point slope is y minus y sub 1 is equal to m times m standing for slope, x minus x sub 1. So this y and this x stay the same. These two come from an ordered pair. So the ordered pair I'm going to use is -2, -7. So this will be x minus -2, and then this will be y minus -7. And then the slope we just said was this 12. So I'm going to put 12 there. So we have y plus 7 is equal to 12x plus 24. Subtract 7 from both sides, and I get 12x plus 17. And that's the equation of my tangent line. Now, if you're not a point slope person, then you have to be a y-intercept person. It's one or the other. You got to do something. So if you're a y-intercept person, your y is equal to mx plus b, and then you're going to use that point, which was -2, 7, so -2, -7. So -7 is equal to 12. That's my slope, times -2 plus b. And then you're going to end up with -7 is equal to -24 plus b. Add 24 to both sides, and you're going to get 17 for your b, which is there, and that's your slope. Either way, you get the same answer. I like point slope because you're doing the same work, but you're just getting the answer all at once. I think it's more efficient, but what do I know? All right, find the derivative function. Use your results to find the equation of the tangent line at 6, 2. So I'm doing the same thing I've done before, but I'm going to have to remember some of those rules we learned before. So I'm going to take the limit as delta x approaches 0. In place of this x, I'm writing x plus delta x minus 2 minus f of x, which is x minus 2, all over delta x. Now, if I were to put in 0, we know I'm going to get that indeterminate. I'm going to get 0 over 0, which means it's indeterminate, which means there's a way that I can do it. And I'm going to have to remember what I learned when I found limits. And I'm going to, looking at this one, since I have the radical, you should be screaming at me, hey, Mrs. Ward, multiply by the conjugate. And you would be absolutely correct. So I'm going to multiply this by the conjugate. And I'm going to take the square root of x plus delta x minus 2. That stays exactly the same. The only thing that changes is this sign here. That becomes a plus, x minus 2. And this is all over the same thing, because in order to keep it equal, you have to multiply both the numerator and denominator by the exact same thing. So I have that written, and now I'm going to multiply. Remember, when I multiply the conjugates, the middle term goes away, the radicals go away, so I'm left with x plus delta x minus 2 minus the quantity of x minus 2. That's me multiplying these two all over delta x times all that stuff. Now, when I distribute the negative sign, we have x plus delta x minus 2 minus x plus 2 all over this whole thing again. I wonder if there's a way I could learn how to copy this and not write. I guess you can't either, so I'll suffer with you. All right, here we go. So the x's will equal 0, the 2's will equal 0, and I'm left with this delta x. I'm left with this delta x over this delta x, which we know we're going to cross those out in a second, but I did not want to skip a step. That. So when I do this, we're going to say that those delta x's simplify. I'm left with 1 in the numerator, and now it's okay for me to put 0 in for the delta x. So I'm going to have the square root of x plus 0 minus 2 minus the square root of x minus 2. So my final derivative, oh, and I got to see the notation we used in the original problem. The notation we used in the original problem was dy dx. Does it really matter? No, but I like to stick with the notation. So I'm going to have 1 over, and then I have x minus 2, so I have 2 of them. And I mean that's a plus sign. This is important. Because this was a plus sign. Why didn't anyone yell at me? So I'm going to have 2 times the square root of x minus 2. So that's the equation for my derivative. So I have that. Now I'm going up here and I want the 0.62. So first of all, I'm going to find the slope at 6.2. I guess we should do that too to be technical. But, so I'm going to have 1 over 2 times 6 minus 2. So my slope will be 1 over, that's 4 minus 2, so the square root of 4. Oh, I'm taking 2 times 2, so I get a slope of 1/4. So my slope is 1/4, the point is 6.2. So I'm going to say y minus 2 is equal to 1/4, and then x minus 6. So I'm going to have y minus 2 is equal to 1/4 x minus 3/2. I think that's right. Add 2 to both sides. So plus 1/2. Right? Better check my math there on that one. Moving on to the next one. Find the derivative function. Use your results to find the equation of the tangent line at the point. So here I go. I'm going to take the limits as delta x approaches 0. Every place I see an x, I'm going to first put in an x plus delta x. So I'm going to have 2 over x plus delta x plus 1 minus f of x, which is just copying down that equation, all over delta x. The biggest mistake in fractions like this is putting this delta x down in the denominator. You have to do that. Now, if I substitute in this 0, I'm going to get 0 over 0, so I know it's indeterminate. Remember when we did these ones before, if we had the fraction, we multiplied by the least common denominator. So in this case, the lowest common denominator is going to be the 2 things multiplied by each other. So I'm going to multiply the numerator by x plus delta x plus 1 times x plus 1. And we'll multiply the denominator by the same thing. Now, when I go to multiply, when I multiply this fraction by this, here, in this case, the x plus delta x's will simplify, and I'll just be left with this x plus 1. So I'm going to have 2 times x plus 1. Then I'm copying down this minus sign, and then here, when I go to multiply these two, the x plus 1's will simplify. So I'm left with this 2 times this. Oh, that's a really bad color choice. I am so sorry. I'll switch. And then this is going to be all over delta x times all of that. You cannot forget all of that. Because we've taken care of multiplying by this, we've got to keep this with the denominator. So I'm going to take the limits as delta x approaches 0. Distributing the 2, I'm going to have 2x plus 2 minus 2x minus 2 delta x minus 2. Distributing that negative 2 the whole line. This is unchanged. So here in the numerator, the 2x and the negative 2x are opposites. 2 and negative 2 are opposites. So I'm left with this negative 2 delta x. Negative 2 delta x over delta x times this. and I'm still taking the limit as delta x approaches 0. I've been great about writing this every single time, and I hope you are too, because I'd hate to take off points for, something silly like that. So there's that. So now, once I get rid of that delta x in the denominator, and by delta x in the denominator, I mean the one that's a singleton, the one that I'm multiplying by, the one that's going to make the whole denominator equal to 0. So I'm going to have x plus 0 plus 1 times x plus 1. So the notation up here was y prime. So y prime is going to equal negative 2 over x plus 1 times x plus 1. So I'm going to write x plus 1 squared. And now I want to find the derivative at the point. Oh, it just has x is equal to negative 9. Okay, well, I can do that first. So we find 8y prime at 9. So that's going to be negative 2 over 9 plus 1 squared. So that'll be negative 2 over 10 squared. So that's negative 2 over 100. So that's negative 1 over 50. So that is my slope. Now I need to find a point. So I have that as 9. So I need to find my y when x is 9. So I'm going to have 2 over negative 9 plus 1. So that's going to be 2 over negative 8. So that's going to be negative 1/4. So my ordered pair is negative 9, negative 1/4. Now, I don't think I made that a negative 9. I don't think I did. I did not. Oh, that stinks. So that's negative 9. Adjust, adjust, adjust. I hope you were yelling at me. So that's negative 9. So this is negative 2 over. That's going to be negative 9 plus 1. So this will be negative 8 squared. So this negative 2, that's a positive 64, because when you square anything, it becomes positive. So this is negative 1 over 32. So that is my slope. So, and I have the point, so I'm going to do y minus my y coordinate, which we said was negative 1/4, is equal to my slope, so negative 1 over 32 times x minus my x coordinate, which is negative 9. Okay, I gotta go teach class. I'll be right back. Don't worry. So continuing to work to solve this equation, I'm going to distribute the negative 1 over 32. So this will be negative 1 over 32x. This plus, so this is coming out minus 9 over 32. That does not simplify, and this is 5 plus 1/4. So now I'm going to subtract 1/4 to both sides. 1/4 when I subtract, I have a denominator of 8 over 32. So my final answer for the equation, my tangent is going to be y is equal to negative 1 over 32x and minus 17 over 32. I know it's not pretty, but that is the correct answer. Okay, the last one, it says if f is continuous at c and you take the limits, and when you do the whole thing for the derivative, you get infinity or negative infinity. That means the equation vertical line passes through f this vertical tangent line is in graph at the point. So if you do the whole limit process, you get negative infinity relating to the vertical tangent line. And then your homework is on the bottom of the sheet of page 262, 13 to 31I. And 35 to 40, 43 to 5. We'll see you next 7 class. Hope this helps.